Hello folks, we're quickly coming to the part 6 video of this exercise 5.5. It's a huge things to do over here. So we start right away. I hope the problem is clear to you from the board. Let's start with the y. Let y be this particular thing. Okay, now if y is this, we know that if this plus sign is coming, we know we cannot take an overall log, so we have to break it up and we have to take, so that way u and v becomes urgent. So you call u as x raised to x cos x, and you call v as x squared plus 1 by x squared minus 1. To start with, we will take u equal to x raised to x cos x. We can clearly see that it's function raised to function, so the only option that you can do here is log u is log x raised to x cos x. The exponent comes up here, so it is x cos x times log x. Okay, and this is log u over here. Next step is to take the derivative d by dx of log u, and d by dx of, now see, this is complicated. Why? Because it's a product of three terms, so that way it becomes a little complicated. For our convenience, we'll call this as one term, and we'll see how it is. X cos x, derivative of log x, and product rule, log x, derivative of x cos x. Yes, so now let's see now how to do this. You know that derivative of log u with respect to u is 1 by u, and because it is with respect to x, we write du by dx. Now this is x cos x, and log x ka derivative we know is 1 by x. Next step, this is log x. Now here to find the derivative, nothing great, it's the product. So once more you have to apply the product rule. So it is going to be x times d by dx of cos x plus cos x times d by dx of x. That's all. So one step extra will come. That's it. So here we have 1 by u du by dx. Continuing with our problem, 1 by u du by dx becoming equal to, the x is, fortunately cancelling. So here it is cos x plus log x times, let's write all this, log x times, first it is x into derivative of cos x, which is minus sin x. That's why I have written minus x sin x, and cos x into derivative of x, we know with respect to x is 1. So only cos x is the surviving term. So here only cos x is left. So in practice, if you want to find out du by dx, then du by dx is, after taking the u on the other side, it is u times cos x plus minus x log x sin x plus log x cos x, or u, in other words, for us it is x raised to x cos x. No need to write one step extra, that can save your effort. So now we will revert back to v is x squared plus 1 by x squared minus 1. Now, unlike all the functions that we have taken till now, luckily for us, v is just a rational function. It's not like it's a numerator by denominator kind. It's not like this function raised to function where you have to take the log then take the derivative. That's not there. So we can take the derivative by applying the quotient rule. So we are applying the quotient rule here to get the derivative. Right away we are finding the derivative. And how do we apply the quotient rule? We have seen if it is u by v, it is v into, v means denominator into derivative of the numerator minus numerator into derivative of the denominator by denominator square. So that is what we are going to write. So denominator into derivative of the numerator minus numerator into derivative of the denominator by denominator square. This is the formula. Now x squared minus 1, those of you are very weak in this and they say that you have to get the u and v, and with that only you can do. As beginners, there's really no harm in doing it. If you are very comfortable like that, then you can do it like that. But with time we will get okay, and so at that time you can use this denominator into derivative of numerator minus numerator into derivative of denominator by denominator square. If you are okay with that, you can do it like that. Otherwise you can assume two functions, some other function f, g you can assume or something like that, and then apply it in the formula and do it. If you are comfortable only with that, you can do it like that. As beginners, we don't know, each of them has different comfort areas. You can do it that way, right? So the derivative of x squared plus 1 is derivative of x squared plus derivative of 1, and derivative of x squared we know is 2x. We have learnt it in the table long ago, and 1, because it's a constant function, doesn't have a derivative, so it's 0. So nothing contributes, only 2x comes. Here it is x squared plus 1, same thing as we did here, derivative of this minus derivative of this. 1 doesn't have a derivative, and derivative of x squared is 2x. So like that, this is the simplified version. And let's now open this up. 2x cubed minus 2x minus 2x cubed minus 2x. So anything is cancelling? Yes. So minus 4x by x squared minus 1 the whole square. Now what happens here? It was our y which was made up of u and v. So here we had a y which was made up of u plus v. So to get the dy by dx, automatically it's enough if you get du by dx plus dv by dx, and all that we have ready with us, so we can have it right away. X raised to x cos x times cos x minus x log x sin x plus log x cos x, and the dv by dx is much more simplified, minus 4x by x squared minus 1 the whole square. That's about it. No, I am searching for the answer just to check whether it is clear. Yeah. So nice and spread. So the next problem is a huge problem actually in your textbook, according to me. Now everybody will feel have different perceptions. So according to me, in that exercise, the 6th problem and the 11th problem should be the lengthiest problem. You feel it. So like some another person X will not feel it like that, another person Y may not feel it like that, but I feel that in this exercise the problem number 6 and problem number 11 is the lengthiest problem. So the next problem 11th which we are taking, it is according to me a lengthy problem, right? So with that we meet in the next video. Thank you.